So today's topic is well, we're going to base this on a documentary that was made, I think, 12 or so years ago, called "The Boy with the Incredible Brain." And "The Boy with the Incredible Brain" centers around a young man named Daniel Tammet. I guess he's probably not quite so young anymore, but since this was 12 years ago. But Daniel Tammet is a guy who could do large calculations in his head. He could he learned numerous languages. Like he knew something like 9 languages, and they had him study to learn another language in a relatively short period of time. And he had memory abilities. They tested him doing things like memorizing um, uh, memorizing position on a chessboard. And sorry, I'm letting some new participants into the room because I just noticed that I hadn't let everybody in yet. Welcome to the latecomers. Linda, did you have 2? Did you try to log in twice?
Sorry about that. I figured maybe you didn't recognize my my school name, so I figured.
No, it's actually just me not being used to what we have to do with the waiting room. You know, I got Zoom bombed along with everybody else, and I started talking and forgot to be paying attention to the participant list. I've got 3 screens, but I'm moving things on top of each other. So hopefully everybody's here. So I was just explaining, we're talking about the documentary from about 12 years ago called "The Boy with the Incredible Brain" and Daniel Tammet. And in early 2008, a bunch of people were encouraging me to watch this. And you know, I like stories about savant individuals. I'm going to go ahead and tell a previous one that I think that the guy for whom the Rain Man movie was based after is Kim Peek. And I don't know if anybody else knows that name, but Kim Peek really is, he is the high memory savant of savants. He reads books very quickly and just knows everything that was in them. You know, just volumes of memory that I have not seen in any other human being. In fact, if it weren't for him, I would not even believe in the idea of a photographic memory, because in my life I've met many people who made the claim, but he is the only one that is anywhere close to actually, you know, performing the claim, at least in my estimation, that I've seen. But I'm going to say I'm taking a very, very skeptical position on the documentary "The Boy with the Incredible Brain," and I'm going to explain some mathematics as to why along the way. And first thing, I'm going to show some clips from this documentary, but first I want to give a few quotes, because I feel like when you read these quotes, you know, when they're read aloud during the documentary, I think they have a little bit different effect than if you read them. I think when you read them, they sound dramatic, like a script. They sound like the way that you would want to create hype, in my estimation. So here are some quotes. "To scientists, this man is a gold mine, a once-in-a-lifetime opportunity. This could be the linchpin that spawns off a new field of research. Since he was 4 years old, he could do huge calculations in his head. If it's true, it blows away scientific theory." Another quote, "His childhood holds a dramatic clue. By most measures, Daniel is autistic, but he's also picked up enough social skills to blend in." And there's a story of during his childhood, things changed very much. And I think the story is, it's interesting that he's both discussed as being an autistic savant, but also being discussed as having had a trauma. And there are people who have picked up, you know, sort of supercharged memory abilities after a trauma. And I'll go ahead and tell you, I have a personal theory that what this is blocking parts of the brain from operating, so that this other part that handles perhaps something like the memory or musical ability, just, you know, there's nothing interfering with it just pronouncing itself more. And so these people do sort of appear the way you expect, you know, savants to appear, not being quite ordinary. But there's a quote when he meets Kim Peek, Daniel does, and Kim Peek tells him, "One day you'll be as great as I am." But when you watch this, in my estimation, and we'll watch this interaction, when he interacts with Kim Peek, I look at Kim Peek and I think, well, that's absolutely an autistic savant. And when I'm watching Daniel, I can see almost an amusement, like the way that I would expect most people interacting with an autistic person, sort of, there's some sense of this person is different than me. And so there is sort of an amusement level, even if we're not trying to, denigrate that person, but their mannerisms are different. And you don't see that amusement among other autistic people. In fact, in my estimation, it's hard to amuse autistic people. Then several times during the video, the scientists who are talking, they talk about how skeptical they are. I'm very much a big skeptic of this, but we're going to go through points where I think they should show skepticism, but fail to. Here's another quote. "It was something that you just can't fake. They're the things specifically that are showing me that he's not bullshitting and he's not scamming. Even the mistakes that Daniel makes are the mistakes that are telling me, you know what, this is legit. A faker wouldn't be doing this." And I'm going to see if I can dismantle that. So I'm going to, before we get going with the evidence, I'm going to point out that about 12 years ago when I saw this, I wrote a long form article on LiveJournal about this. And over the years, numerous people contacted me about this article. And a book was written. I think the author of this book probably found my article and used it to back up directions of his own research. And I'll tell you about this book before we start watching some of the Daniel Tammet video and going through my actual mathematical reasons why I'm skeptical. But the book is called Moonwalking with Einstein, and it's written by a guy named Joshua Foer. Has anybody heard of this book?
Surprisingly, I have.
It kind of became a popular read very quickly. And what it's about is this guy Joshua Foer, who didn't have any particularly exceptional mental abilities. And just reading him, he's an intelligent author and he sounds like an intelligent guy, but he had no particular abilities to memorize large numbers or pages in a book or anything like that. And but he wrote this book. He went on his own search. There's like a world competition for memory. And one of Daniel Tammet's claims to fame was doing very well, performing at the highest levels of this memory competition. This guy, Joshua Foer, decided he wanted to see if he could, as just an ordinary person, train himself to win these competitions. And if I recall correctly, it's been a while since I kind of sped read the book as well as I could, or thumbed through it. And I stopped and read several of the chapters very completely, but I think he won the world competition. I think it's the story. And he interviewed a lot of the people who were very good at it to figure out what they were doing, how they were studying, and then tested himself to see if he could actually do it. And it took him I don't even know, 2-3 years to become the master of the world in these memory competitions. And along the way, Daniel Tammet was one of the people that he interviews, but he seemed to decide that Daniel Tammet was not above board. And I'll explain chapter 10. He talks a lot about Daniel Tammet. He says that oh gosh, I think this is right here. Yeah, right here. You can read this yourself. Daniel Tammet claims to see numbers in terms of shapes and colors. He claims that his profound performative ability with arithmetic comes from synesthesia, and seeing shapes and pronounced images in various ways, colors among numbers, up to 10,000. But Foer tested that, and he didn't let Daniel know that he was testing it. He asked him on multiple occasions about the same number and got 2 different responses. And I think in the book he explains he thinks that Daniel caught on and stopped answering his questions. So yeah, or he stopped answering his questions in the same descriptive way. So it's interesting. Also point out that Daniel was tested by Simon Baron Cohen, who and if you guys know Borat, that is his brother. The Sacha Baron Cohen. His brother is a brain scientist. It does brain imagery research, if I understand correctly. And he did an image of Daniel Tammet's brain, and he said that he believed Daniel Tammet, but I'll explain later why I think that he could have been fooled. So I think that Ford may have caught my article, but a guy who definitely caught my article was a researcher from, I believe, Argentina named Andres Anibal Riesnick. And 3 years ago, Riesnick contacted me, and I got on Skype with him, and we had several sessions. Riesnick, he had begun, I can't remember why or what he was doing, but he had begun to do his own, neuroscientific research. And I'll tell you this, Riesnick he's a physicist, right? He did more hard science in his previous background. So when he started, veering just his personal interest into this brain science area, he got caught up looking through all the science and thinking and feeling like, hey, I don't think this is all above board. So he took a very skeptical approach, and he started publishing, and he came to the conclusion that that Daniel Tammet may not have been above board. And so now I want to start breaking down the reasons why I think that's true. I'll also point this out. Once he started publishing this, his publisher actually started to put the brakes on and wouldn't give him an explanation as to why. And then he got personally harassing and threatening phone calls from what he felt was the Colombian mafia over researching whether or not these previous papers were, good science. And just to give an idea, this guy, Riesnick, he's kind of the Neil deGrasse Tyson of Argentina. He has like his own television show, and he is, he's a solid physicist, very well-respected guy. So let's go ahead and start taking a look at what some of the claims are. So I'll show a clip from Moonwalking with Einstein that's very early on in the video. Uh-oh, can you guys hear this?
No.
No.
There's an option when you share your screen to share system audio as well.
Thank you. Where's that option?
When you click the share button, it shows you the screens you can share. At the bottom, there's a little checkbox.
Okay.
Yeah, the problem is that the computer sound isn't the same to me as everything else, so I'm hearing it very low volume right now. Let me see if I can fix that real quick. Maybe that was it. I go back and forth between microphone and headset.
Daniel Tammet claims that since he was 4 years old, he's been able to do huge calculations in his head. So, in August 2002, we dropped by, armed with a calculator.
And you can't see this calculator that I've got here, can you?
We first asked Daniel to multiply 37 by itself, 4 times.
Okay, 37 to the power of 4. One million. Yeah. 874,161.
Okay, I'll go ahead and stop there. So it sounds like it takes him a little over 30 seconds to perform that calculation. And you can see he's moving his fingers, right? So this is a guy who claims, and it seems the scientists are making this claim in this documentary, that he doesn't actually know how he's performing this arithmetic. And just watching him right there, watching his hands, it seems absurd to me, but I want to walk through what this calculation actually is. And this is going to become important because we're going to see a common thread with all of the calculations. I think that they are all softballs in a particular way. So this is 37 to the 4th power. Now I'm going to point out 37 squared. This is something, like at this point, I know this one by heart. And so I don't actually have to spend much time doing it. But if I were to do this as a computation, I could do it like this. And x minus y squared is x squared minus 2 times x times y plus y squared. Algebra, because we have so many archetypes, x plus y squared is such an it's one that you can't get out of your brain once you've studied your algebra 1, right? You just see it so many times, it's so reinforced. And this is, we use an anchor like 50. And then really the hardest part of this is the addition and subtraction. It's just putting it together. We get 1200 and we add 169, we get 1369. And once you begin to practice this, it's something that can be done quicker and quicker. I routinely teach 9, 10, 11-year-old kids to do this computation in a couple of seconds. The next step is tougher, right? What we want is 37 to the 4th power, which would actually be 1369 to the 2nd power. But again, I think that this is a computation that is much easier than it looks. And somebody who practices this can do it, I think, faster than Daniel. In fact, all these calculations, I would say right now, without practice, I could do them maybe 20 or 30% faster than Daniel. And I want to point out that's uniform across all of the calculations that he does. And when I was in practice, I probably could have done them 3 to 5 times faster. This one in particular, I would do this one of 2 ways. I would either make it 1400 minus 31 and square it, or I would make it 1500 minus 131 and square it. And even though usually I don't like to use 3-digit numbers in these differences, 131 is a relatively simple one because it's within 1 of a multiple of 10. And so if I had to square that in my head, I'd start with 130 plus 1, 16,900 plus 260 plus 1. So 17,161. So not that bad. But I'll go ahead and do the 1400 minus 31. We get 1400 squared, which is 196,000, 1.96 million. And then minus 2 times 1400 times 31. And this is going to be the hardest part. The 31 squared at the end, I'm not worried about at all. If you can do mental arithmetic, 30 plus 1 squared, 961 isn't too bad. But 2 times 14 times 31, how am I to do that? Well, 2 times 2 times 7 times 31. 31 times 7 is 217 times 2 times 2, which is 4, is going to give 868. And so add 2 zeros to the end because it was 1400. And now the biggest obstacle here is the subtraction part. But we've got a number that's a little less than 100,000 being subtracted. So, we'd go 1,860,000 plus 3,200. Sorry, 3,200. And then with the 961 at the end, and that would give us what, 1,864,161, and no, 132. I subtracted 100,000, so 1,874,161. Anyway, sorry, talking and doing this is a little bit harder, but this is something that I can do in my head in probably 15 to 20 seconds ordinarily. In fact, John, who's hugging his son right now, John and I were on math team in middle school, and we would actually make games out of doing this. We would try to, learn how to do math counts tests as fast as we could for the middle school math competition. And so we would practice a lot of these together. And it was, squaring 3-digit numbers was not a particularly, complex task among all these. So the next one, however, this is one that really, really interested me. It was the one, like, when I saw him do this, I wasn't really sure what was going on yet, because this might have just been one random example. But the next example that I want to show is one that made me immediately skeptical. Sorry.
Next,
let's say
we asked him to divide 13 by 97.
97.
Fractions are tough.
0.13400206.
That's as far as my calculator goes. Brilliant.
185,567.
You're carrying on.
I'm carrying on. Do you want me to stop or?
How many points can you do it to?
100, nearly 100.
Maybe 100. I don't know why he would stop there. Maybe 100. But I guess that's the answer you give if you're trying to convince someone that you're seeing this as colors and shapes as opposed to actually doing some kind of a calculation. But I'm going to point out what this is. I'm going to do a different version of this problem first. Here's the version I'm going to do. Let's do 13 over, instead of 97 like he did, let's do 13 over 98. 13 over 98 is 0.13265306124489799591. This goes on and on. In fact, it has 42 repeating digits. It has a non-repeating digit and then 42 repeating digits. And so I could just spit them out as fast as I can write them down, or faster, really. So let's talk about what's actually going on here. You might notice, a pattern with somewhat doubling of the digits, and you might have even seen this. At least it's very close to looking like doubling of the digits, pairs at a time. And you might have seen this with the number 1/7 when you were a kid, when you saw that this was like the first like really spectacular repeating decimal, right? It's like 1/3 is kind of cool, but then you go 1/7. Wow, that's crazy. But you look at the digits and you go, oh, 14, 28, double that is 56, and then we have 57. So what's really going on here? Well, what's really going on is that repeating decimals are infinite geometric series. And if you stop and think about it, you go, well, this is an infinite geometric series. How can I look at it that way from the beginning? And if we take a geometric series, first term A and common ratio R, give it a name S, name the beast, multiply it by the common ratio, and then subtract. We get rid of the thing that's difficult, which is the infinitude of terms at the end, right? Everything cancels except that first term on the right-hand side. So we factor out the sum variable on the left, and we have a formula for an infinite geometric series. Well, let's take a look at 13 over 98 in terms of this formula. We want to write this as something, first term A over 1 minus a common ratio. But what we've got is something that is over, it's close to a power of 10. Powers of 10 are convenient. We can divide by them or multiply by them very, very easily. We're just moving decimal points over, right? Well, here, if we divide that out, we have 13 100ths divided by 1 minus 2 over 100. And now let's compare this to that form right there, that formula for an infinite geometric series. Well, we realize our first term is 13 over 100. Our second term is 2 over 100 times that first term. Our third term is 2 over 100 times that, and so on and so on. And when we look back up at the digits, we realize, oh yeah, 13, 13, 26, 26, 52, well, 53. Where does that extra one come from?
4 over 10 to the 8.
Say, what's that, Johnny?
104 over 10 to the 8. 104 divided by 10 to the 8.
Yeah, got it. Yeah, we carry. Exactly. We're going to carry from the next one over. If we'd said, hey, this was 52, and then the next one was 104, and then the next one was 208, we can see the carrying of the terms making the digits that we want. And that seems to make things real complicated, right? But here's the reason I can still do this fast, is because if we just start doubling the carrying, then we're handling all of the future carrying as well. And so all you really have to do is know that since we have a gap of 2 right here, that every time we get beyond half 100, we have to add 1. And so what I do is I say 13, 2, 6, double that is 52, add 1, 53. Double that is 106. We already dealt with the 100, so it's just 06. Double that, double that, double that. Then we double and we get over the halfway mark to 100, so we add 1. Double that, we get 194. But we've already counted the 100, but then we add 1 to the 94 to get 95. And so, up here is where it gets a little bit harder, but it's still, if you're fast with arithmetic anyway, it's not going to be, a crazy big deal. But obviously what he's doing, if you understand the arithmetic, then what he's doing is not that crazy. Now, this doesn't prove that he's not doing this with some sort of synesthetic activity in his brain that he can't understand. But I'm going to point this out. One, all of the things that he's doing scale in terms of time with the amount of time it takes me as an arithmetic expert to perform them. Also, he works professionally, as they say in the video, as a math tutor. And if you're not sure how you're doing things, it seems like it would be a hard thing to teach other people how to do it, right? So, that immediately grabbed my attention and made me skeptical. So at the beginning of the documentary, these are what I consider 2 very softball problems. They happen to pick numbers that we could apply most easily to this methods. I want to point out what they did not do. They did not ask him to do 13 over 103. And if we tried to employ this method with 13 over 103, it actually turns into a negative common ratio. And this is something, I know how to manage this, but it's also icky. It takes me about 2 or 3 times as long once I get past the first few digits. And it's, if I practice it and I have the method down, I can do it real quick, but I haven't practiced it since I was like 13 years old. But it would be much harder if they had asked him something, but they asked him one with a denominator that was just under 100, right? That happens to be prime and have a 96-digit repeating decimal, which is so far that you're just not going to figure that out looking at a calculator. You might not even know how to figure out how many repeating digits are in it without a good bit of number theory. But somebody who plays with these arithmetic games, they figure these things out. So I think this is not so spectacular. But so I started to be skeptical, and let's walk down a little bit further path. These are the 2 that are shown in the video. And to me, this is interesting because you make a video, you make a documentary like this, and there's probably a lot of footage on the cutting room floor, right? What they never did, at least that they showed, was ask him something like, what is 463 times 887, right? They only asked him to square numbers. And the reason that I point this out is, if I were to try to come up with my best way of doing this in my head, or maybe 1,000 minus 113, but I'd probably go with 900 minus 13. If I were to do this, I can do this, but it takes me a lot more time because I have 4 different numbers to deal with, right? That's much harder than if I just have to deal with 463 squared. If I have to deal with 463 squared, that's 214,369. It's 500 minus 37, and we just happened to be discussing 37 earlier, squared, and I can do the x squared minus 2xy minus y squared method, which gives 250,000 minus, 37,000, which is 2 times 500 times 37 plus 37 squared. Not that big of a deal if you are somebody who has practiced this. And like I said, I practice this with students who are as young as 9, 10, 11 years old, but often any teenage years, or I've done this with adults as well and taught them how to do it. So yeah, it's easier if you're having to keep track of fewer numbers. So in other words, it seems like everything that they throw him is a softball. So the video goes on, and they're so impressed with Daniel that they take him to other researchers. In the meantime, they kind of point out, they show a video. Has anybody seen the Fast Abacus Kids? Like in some countries, they do it definitely in China and in Japan, and maybe also in India. I know that the Vedic mathematics in India, they have people who do that very fast, but I don't know if they're doing What these kids are actually doing is they're visualizing an abacus. They learn to do this first on an abacus, but then they learn how to multiply like 3, 4, 5, 6-digit numbers, doing it that way on the mental abacus, and it's phenomenal. When I was a kid, I actually wondered, was I as good as like anybody in the world at doing that kind of mental arithmetic? And when I saw these videos, I decided definitely not. What anybody can learn to do with enough training is way beyond what we think. And so when somebody tells us that they think differently, that it's different processes in their brain, we should probably be more skeptical, because we do have evidence of training people in large numbers. This isn't just like my students that I get who are, top 2% math students, and then I work with them and I take them farther. And I've had, all kinds of kids go on to study math at MIT and Harvard and Stanford and places like that. It's not like that. These are rooms full of kids, from one location, essentially. I grew more and more skeptical watching the video. Later, they take him to meet some researchers. I don't know if they were from India, but let's take a brief look here.
Neuroscientist Professor Ramachandran and his team are intrigued by the idea.
Kill another video.
The world's most versatile team.
But have their doubts.
When Rama first came to me and said, hey, we've got this math savant that's coming here, and he can do 4x4 multiplication, and he can recognize primes, and he can do division out to so many decimal places, I thought, yeah, he's probably faking it, or he's got it memorized. There's all sorts of techniques, and I'm very much a big skeptic of this.
With the pleasantries over, the testing can begin.
27 to the power of 6. Oh, can you do it to the power of 7?
Yes,
okay. 27 to the power of 6. Can you do it to the power of 7? And he says yes before he even tries. Maybe he just knows how many digits that's going to be, and he's practiced that far. But I want to point something out. 27 is itself 3 cubed. So 27 to the 7th power, which is 3 cubed to the 7th power, is 3 to the 21st power. And just having played math games as a kid, I used to know all the powers of 3 just off the top of my head up to the 20th power of 3. I think I can go up to the 12th power of 3 right now, just remembering that. The 12th power of 3 is 5, 3, 1, 4, 4, 1. But the 10th power of 3, which is the 5th power of 9, is 59049. And I bring that one up because if you were trying to compute 3 to the 21st power, I think this is actually easier than 3 to the 18th power. And the reason is because you get to piggyback off of the square of that. 3 to the 20th power, which is 59049 squared. That's 3 to the 10th squared. And this right here, we can break down into 59,000 plus 49 squared. And so now we have x plus y squared, where the hardest part of this is saying 2 times 59 times 49, which is like, 59 times 49 is very close to 60 times 50. 60 minus 1 times 50 minus 1. That's 3,000 minus 110 plus 1. So 2,891. That's the hardest part of all this. So we can relatively quickly come up with 3 to the 20th power. And and then 3 to the 21st is going to be 104,603,53203. And let's see.
It's amazing how much of a math solving spectacle you're providing while we're at it.
0.
And as the calculator doesn't even have enough digits for all that, right? But there's a 03 at the end. And they actually, they test
4 6 0 3 5 3 2 0 3.
Excellent. Better than the calculator. I need to see whether or not that 03 is correct, but I have a feeling it would be.
These powers, they roll over every power. They roll over like the last 2 digits. If you take 21 powers of 3, 4, 5, 6, 7, your last 2 digits are going to roll over in repetition at the very end. So it's the same as 3 to the first power. There is a reason for that, but I don't want to go through it right now. There's something called Euler's theorem in number theory, but there's a little bit more to it to realize that there's that it's exactly 20 as opposed to some other number like 40. But anyway, this is once again, it's a softball type problem because there is some clever approach to it, right? And they don't seem to be asking that. And they don't seem to be they don't seem to care consulting anyone who might be like a super lightning calculator. I'll go ahead and tell you, there is a guy out there. Like I'm one of these lightning calculators, but I did not push my ability to be performative in this way, right? There's a professor named Arthur Benjamin who does the performative aspect. He's a little bit better than I am at it. I think I could practice and do as quickly as he does. But and then there was a guy years ago named Scott Flensburg, and he actually had infomercials. And I don't know if anybody here ever saw. He had his own method. Was he the Trachtenberg guy? He might have been. He may have. Anyway, he called himself the Lightning Calculator. I actually met him when I was 12 years old at a national math competition, and he would teach these types of methods to kids. And so.
Is he the one who said start counting with 0?
I don't know. I don't know if he said that. I never actually watched any of his videos. I met him, and when I met him, he asked me. We talked a little bit about doing mental arithmetic stuff, and then he taught me the method for like telling what day of the week a birthday is on. Like Tanya, what's your month, day, and year that you were born on?
September 23rd, 1989.
September 23rd, 1989. You were born on a Saturday, I think.
Yeah.
Yeah. And so he was one of those people who would do that method like lightning fast. Like he could have just spit it out the moment he heard your birth date. But yeah, he would practice and he would teach those methodologies, and he had an infomercial with his whole system that he would sell to people. So there are plenty of people out there who can do these types of things. And I just want to point out that once again, what I see is a similar speed in the solve from Daniel, right? This is exactly like what I've seen with other people, but he does one more, and we'll talk about this one more in a moment.
31 to the power of 6.
31 to the power of 6.
Daniel's jet lag is wrecking his concentration.
Daniel's jet lag is wrecking his concentration. He does wind up coming up with this in a few seconds, but I want to go ahead and go to the solve. Let's talk about how this might be done and why it might not be quite so impressive as it looks. This is 31 to the 6th power. And I'll point out they didn't ask him 43 to the 6th power or 26 to the 6th power, which might have been tougher to do. There are two different ways that I think this can be done rather easily. One of them is 30 plus 1 to the 6th power. And if you know your binomial expansion theorem and you know your Pascal's triangle, or you just compute 6 choose 1, 2, 3, 4, 5, 6 pretty quickly. What we're going to have here is 30 to the 6th plus 6 times 30 to the 5th plus 6 choose 2, which is 15 times 30 to the 4th. 6 choose 3 is 20 times 30 to the 3rd. 15 times 30 squared, 6 times 30 plus 1. And so it's binomial expansion theorem, x plus y to the 6th power. Or there's another way, and I suspect he actually went this latter route. I think that if I were doing this, because I know so many squares, because I've done them so much, I know that 31 squared is 961. And I recognize that readily. Anytime we can get close to a power of 10, we're giving ourselves this anchor advantage, this huge advantage to work from. So we'd have 1,000 minus 39 to the 3rd power. Now, I don't know for sure. This one may or may not really be easier. X minus y cubed is x cubed minus 3x squared y plus 3xy squared minus y cubed. And let's plug in the numbers here and talk about exactly how tough this is or isn't. That's 1,000 cubed. Okay, so we're starting at a billion. 1 with 9 zeros, a billion, minus 3 times a million times 39. Well, that's not too bad. What we have is 1 billion minus, I'll draw that out, minus 3 times 39 times a million. So that's 117 million. And I'm not even going to bother adding that in yet. I always do that kind of stuff at the end. Plus 3 times 1,000 times 39 squared. 39 squared is 1521. Again, we can do 40 minus 1 quantity squared. Do it that way. But I've done this so much that I just know that one off the top of my head. Minus 39 cubed. And the toughest part about this is the 39 cubed. Everything else, though, is easy enough that for somebody who does this regularly, it's not a problem. This is the big part. You can keep all this stored relatively easily or just compute it later. You might even I'd have focused on this from the start. This is the piece I would have done first because I know it's the hardest part. I know it's the part that I don't want to store in my memory long term. I only want to keep it there for a few seconds at a time. But 40 minus 1 cubed is going to be 40 cubed, 64,000, minus 3 times 1,600. Plus 3 times 40 minus 1. So we've got 59,319. And I don't know if anybody's checking with a calculator, but one thing that I might do to check before going on, I know that this needs to be a multiple of 9. 39 is a multiple of 3. The cube needs to be a multiple of 9. I'd look at the digits and perform a digit sum check. The sum is 27, which is multiple of 9. Therefore, that number is multiple of 9. So I'm pretty sure that I've got the right number. So I think that that's how this solve is performed. And once again, this is not a random number. This is not 37 to the 6th power. This is 31 to the 6th power, which happens to have an intermediate step that is very, very close to 1,000. And here's the thing, if I'm right about that. Now, we heard a clip where one of the researchers, I can't remember his name, one of the researchers, curly-haired guy, said even his mistakes seem, like something that could be genuinely going on. But the way they explain it in the video, they even show like a graphic where he's got the two numbers he's multiplying and this number appears in between and it's the correct number, right? If you're doing that, why would you make mistakes? If there's some mechanism that's going on outside of your control, well, it's a mechanism that's statistically accurate to some degree, but not always correct. It seems like a very, very weird thing to have happen. When we, there's something called DNA computing. Actually, I worked for a company that had DNA computing researchers years ago. And the idea was to try to, be able to solve problems by having DNA like just randomly combine many, many times over, and for one of those to be like the ultimate solution to a problem. It's a very quick explanation, at least. When you have something going on like that, when you have mechanisms that are automated on their own, you don't expect there to be, like just a statistically right or wrong answer. And to the extent that something like this is wrong, we should be able to fix it in many ways. If I were doing a computation, just like I said, I would take a look at whether or not the sum of the digits here is a multiple of 9. I usually know. I know usually 90% of the time within a second whether or not my answer is wrong. Because when you play with numbers like this, you see all the different ways to check yourself. It's kind of like parity digits in information theory. If it's going to be useful at all, you want to check it. So I'm very, very skeptical of that idea. But I do want to say this. He does do some very serious feats of memory display. This is a guy who memorized something like 22,000 different digits of pi and could recite them in order. And I don't know if anybody's ever seen this before, but there are entire competitions. In fact, I've taught at math camps where they have done competitions like this. But here's a note when I was doing some research about this, where he says he would absorb like hundreds and hundreds of digits at a time to get to 22,000. This doesn't strike me as right. If you're trying to be the best in the world, like break a world record as if this is, something magnificent, it feels weird to chunk things into, 2 or 3% or 4 or 5% of the entire load that you're trying to perform. I would think that you would be able to do this many, many more times over than that. If you could chunk 1,000 digits in a day, then I would think you would be able to do that for, I don't know, a while in a row. But aside from that, and that's not the biggest criticism in the world. But here's something that's very interesting that came from the book Moonwalking with Einstein. When Daniel Foer was investigating Daniel Tammet, I think he had reason to doubt Daniel Tammet. So he went to his history and he found that Daniel Tammet had actually changed his name, what looked like multiple times. And, that alone was kind of weird. Like, was he, what was he doing? Here's this guy who's, I don't know if he's in his 20s or early 30s when that video was made, but not particularly old, but, he's been doing these world memory championships. And he had written a book. And Tanya mentioned she had read the beginning part of this book. I believe that he wrote this book long before these scientists found him and did this, discussion of memory stuff with him. And he may have even written it under a different name, or maybe he wrote 2 books and he wrote the second. I'm not 100% sure of the story on this, but he did change his name, which obscured some of his history, including work as a telephone psychic.
Telephone psychic.
So that was one of his jobs, apparently, was working as a telephone psychic. And then, of course, we have the evidence where Joshua, after interviewing him, became skeptical and asked him the same large number, what its shape and color was, and was given different answers. And so, some things don't seem to quite. But in particular, though, he was long before these videos were made. I think this is how the researchers found him to begin with, was that he had done well in these massive memory competitions. And in coaching other people and in writing the material that he did, he was working as a professional memory coach. He was using something called the Palace method. And has anybody here ever read about the Palace method for memory? Do you guys know about this?
As popularized by Sherlock.
Popularized by who?
By Sherlock.
Oh, was it popularized by?
Yeah.
Oh, I think I did see that it was on the TV show, but I think it was sort of quasi-popularized, like among geeks before that, right? But yeah, I guess that probably brought it more into the mainstream to hear about it. I'm gonna Google this real quick and see if something shows up, like a Wikipedia article. Memory Palace, a powerful technique. Yeah, and this kind of gets advertised. It's one of those things that makes me cringe, when I see pop science discussing the mind and memory and all this kind of stuff. I think claims get made that are far, far beyond what it is that's actually going on. And I think, unfortunately, anytime you have even the potential for, a fraud not to be uncovered by skeptics, and I don't want to put an exact label on my opinion of Daniel Tammet or the people who made the video, but I let's just say I have a very high degree of skepticism. I think that we actually hurt science a great deal, and that what I've seen written about the Memory Palace in particular seems to be built on some sort of, I don't know, almost like supernatural image of what this is. Like, you can do this too, but you are tapping into your inner potential and seeing with your third eye, and like it grows to kind of a cultish epic proportion or story. But yeah, he was using this method, which is well known. It's been documented for centuries, in fact. People create context for the things that they're memorizing by imagining this palace in their head and imagining these rooms, and each thing they memorize, they go and they put it in a particular room to remember what it is and where it is, and that way they can go and sort of retrieve it with their mind. And I think this is kind of like Dunbar's number. How many people here have heard of Dunbar's number? So Dunbar was a sociologist or anthropologist who noticed that the larger primates got, the larger the groups they hung out in, and he theorized it was the brain size that mattered. Like those little, I think they're called like cotton monkeys that hang out in like the canopies of big trees in South America, and they hang out in groups of like 8, and that's it, just 8. You get to larger monkeys and they hang out in groups of 12 or 20, and then you have troops of like 60 baboons at a time, right? But you get up to humans, and we look at prehistoric humans, and he surmised 150 in a tribe. And I think that number has been debated a little bit, and we get kind of a range of like 150 to 300. But the idea is that it's based on our brain's design. The evolutionary stage at which we are can handle a certain amount of information, just on a natural level. We can handle perhaps 150 to 300 ordinary social relationships where we really truly know each other. And I think that something similar is going on with the Mnemonic Palace, which is the Memory Palace, which is that there's a certain amount of space that you can put in your palace for short-term information retrieval, right? And this is why I think Kim Peek is so exceptional. I mean, he really is just this off-the-charts, memory ability, just being able to thumb through books and know everything that was in it in a few minutes. I mean, that's just incredible. I don't know about you guys, but when I feel like I'm learning a whole lot, it's because there's great context involved, right? We all read history, and at first we're memorizing things, perhaps, or that's the way we're tested in school at least, but eventually you learn enough about certain stories that you understand what's going on in context. And then suddenly, even things like dates begin to stick in your head much more easily. And so, we have this ability to absorb things in a particular way with good scaffolding, with good context. But as far as just absolutely pure memorization, I think that we have a certain capacity for it. And the people who figured out that the Memory Palace technique works, it does work. What they're doing is they are learning how to interface with their RAM. And they're holding that RAM constant for as long as they need to perform any kind of significant feat, jump through some hoops, perform well at a memory competition. And then they erase it and go. As far as I understand, I never learned the Memory Palace technique, never practiced it enough for it to be part of my meditation, at least. So I think that, and of course we have the author of this book, Foer, who himself learned all these techniques, and he went and he won the world memory championships. So, thinking that through and thinking through the fact that all of these feats of arithmetic seem to scale with what I know and what I've also, taught other people to be able to do, it seems like there's just not, terribly much to this. But I want to point out See, I've got a couple other videos that I thought were kind of telling. Let's see, there's one on Blackjack where they take him to Vegas because, of course, that was part of the story of Rain Man, right?
Hi everyone, Eric here,
Tom Cruise,
and we're going to talk today about choosing the perfect
Dustin
domain.
Hoffman, whatever their characters.
Blackjack, the dealer has the advantage. But even for a card counter, it still comes
Anybody
down
ever
to
tried
chance.
that? Actually worked with a guy on Wall Street.
So it's actually really hard to concentrate because the black lights, the noise, the atmosphere, a strange mixture of tension and excitement all in one.
But it doesn't even look like, it doesn't look
Daniel
like
has
he's
played
actually,
2 rounds with 8 decks
I don't know,
each.
maybe he's counting.
That's over 400 cards to keep track of at once.
But that's not really what they present in the video here. They present a very rare
Round 1 is a
split that
disaster.
happened to happen.
Daniel's
while he
chips
was
are
playing
disappearing
Blackjack.
fast. And memory
Where
alone just isn't giving him an edge.
The dealer had
Eventually,
an
he
evil
changes
card,
strategy
and he had 7s,
and follows his
which
instincts.
is, you know,
At the end,
a
I
difficult
was just
split.
relying on intuition
period.
and the imagery as it flowed
Because
into my
17 is
mind.
hard to hit.
At the most unpromising moment, Daniel decides to gamble.
The
Daniel
house had a
decides to
10.
gamble.
which
I don't know what
was
this has to do with anything, but he
and I was
decides to
given 2
gamble.
7s, and that's not a good hand, and it's particularly not a good hand against a 10. What I decided to do was split the 7s. An unusual move.
Split the 7s against a 10.
Statistically
Which is an
speaking,
unusual
not
move.
the best move.
It's in fact
but
kind of
something in my head
bonkers.
was telling me to do that anyway because
I don't
of the
think that there's
imagery that I was
anything
experiencing, and so
count
I split
that
the
would,
7s, doubled my
suggest
bet,
what's about to happen
was
here.
given a 3rd card, and it also turned out to be a 7. And at this stage, I wasn't really sure of the
twice.
rules of the game because this is the first time I've played Blackjack in a casino. So I asked, can I split those 2? And she's surprised, but she says, sure, if you want to. So she splits those, and so I now have 3 hands at one time against a 10. And the people behind me are tutting, and they're saying, what is he doing? You know, he's playing 3 hands against a 10. He's splitting 7s against a 10. He's crazy. And then she draws the remaining cards for each 7.
He hits 21 on his first hand. And again on his second. That's 2 out of 2. Who'd bet against a hat-trick now?
It's 321.
His 6th sense proves a winner. And in one fell swoop, Daniel squares his losses.
Did you get that?
Did you get that? This doesn't sound like an autistic person to me. This sounds performative. This sounds like a person who's absolutely in tune with other people's reactions to what they just saw. And that was a very rare moment. In fact, it was an absurd moment. But it had nothing to do with whether or not he could count cards. And that's basically the best they could come up with for a trip to Vegas. So, yeah, I guess he got to go to Vegas and play with money as part of this video. And I don't know what that displays about the story at all. It just kind of seems absurd. So, yeah. So, oh gosh, those pieces, I don't know if I got a good clip for this, but let's see if this is it. I'm gonna have to wait through another video, but that was another autistic man that you can see was having kind of a
Bane's language and social
meltdown
skills
moment.
remain childlike, even as his art becomes richer.
He really pays attention to the little minute details, but he would put the emotion in. He loves drawing in the sand, and he enjoys watching the waves come in and wash it away and then draw something else because he draws really
I think
quickly.
this is
So
mostly
he
just a
likes to see
perspective on
things
another autistic
changed so that he can draw something new.
has, autistic talents and like
How is
draw
this
shape.
remarkable boy seeing the world?
And just drawing shapes.
It would be
as far as I can
fascinating to
tell, the
know,
only tie-in
if only
to
he could
Daniel
do.
is that he's claiming to see numbers as shapes.
What makes Daniel different from savants like Dane, and so extremely valuable to science, is that he can describe what's going on inside his head.
I experience numbers in a very visual way, using colours, texture, shape and form, sequences of numbers form landscapes in my mind. It just happens. It's like having a fourth dimension. One, for example, would be very bright and shiny number. It's almost like somebody flashing a light in my face. You know, it's a very interesting experience. Number 2 is kind of like a movement, right to left, kind of like a drifting motion. 5 is like the clap of thunder or the sound of a wave against a rock.
So all these are very sort of slow, descriptions, very, dramatic descriptions of numbers and colors and such things. But yeah, he's doing, vast computations with these. But I want to go back for a moment. If you heard what the narrator just said, he said what makes Daniel so valuable is that he can explain what's going on. But what we have are all these examples, all these times when he's done these large computations where he basically said, no, I can't explain it. And they don't stop and have him explain any of it. And they're throwing these softballs that, we can clearly find other, exceptional methods to do, but they don't seem to be giving him random numbers. They only seem to be giving him numbers that feed into, and so one of two things happened. Either they allowed him, I think, this is my opinion, they allowed him to coach them on what they could ask. Or there's a lot of footage on the cutting room floor that we're not seeing. And so it's just the number of things that make me doubt this build up and build up and build up. But we've gone for an hour now, so I'm actually going to stop here and just take questions and let you guys tell me what you think of this case and the conversation and what it is that people can learn to do.
I think it speaks a lot for actually how little people try to persistently learn things that they cannot even tell an adequate estimate of what is within the bounds of acquired skill.
Yeah, and I think and part of what we should recognize is this is what makes a lot of performative art. When you see Penn and Teller or other really excellent magicians, every now and then they kind of pull back the curtain and teach you some of their secrets. And when you see the secrets, you see, oh, okay, I see how that was done. It's not actual magic, right? It's fantastic illusion. But even when you see it, you go, that took a long time. That took a really long time for you to make your hands do that and do this. And I didn't even notice. And there was all the good misdirection or even the inventing of props. A lot of the props that they use are just so clever. And I think that's what goes on with a lot of these kinds of performative mental feats. There is good, interesting engineering behind it. But there is also, I think that there's a magician's art that goes on. And actually, there's somebody here. Johnny actually knew me as a kid. I think we met when we were 12 or 13 years old. And I would actually do this from time to time because there would be people who would go, oh, you're so amazing at math, blah, blah, blah. And they might see me like square 3-digit numbers or something like that. But then I would sometimes just like jerk people's chain a little bit. Like I would make it into a performance act and actually, test and see how far I could push a claim just to see what it is that, they might acknowledge believing about what I was doing. And it was something that I probably did for a couple of years, just out of curiosity as much as anything else. And I could see that sort of, magician's game going on. So I think that, unfortunately, there's some bad science going on, but it makes you wonder, how much of science is performative at this point.
It's actually interesting. Maybe, gosh, I don't know, 5 or 6 years ago, maybe even longer at this point, there was a little bit of a sort of like research expose. So, there are all of these famous cases of neurological divergences where certain things are happening which are interesting to researchers. And so sometimes people will make an entire career studying a brain function based upon one case. And I can't remember what institution it was. Maybe it was Harvard or Yale or something like that. But there were several of these like very famous cases that made people's careers back in like the 50s and 60s and 70s. And after the researchers had died, they released the archives, and people started going through the research notes, and we're just like, you know, we don't understand how they made these claims based on this one subject based on their research notes. But, you know, accessibility to that one individual was what made that person's career, and the access was restricted. So there weren't other people who could then come in and dispute the characterization.
Oh, I remember this now. I remember this story. There was a woman, what did she have? Like legal rights over a brain or something?
Something like that. Yeah, it might have been involved in a lawsuit as well. Maybe that's why there was disclosure of the archives.
I think that's right. And it's one of those, you know, does science progress one funeral at a time types of stories. Here's one that I just looked up to, the Sokol affair, where
he was my professor at UCL.
Oh, interesting. What was, did he ever talk about it?
Yes, he did. He was just this crazy guy who really hated all the bullshit. So at one point he decided to spoof like a completely ridiculous article and submit it, and it got accepted. So it was before the time, you know, that people were like later people would you know, use AI to write these bogus articles, but he just wrote one in I don't remember. I've read the abstract from it. It was as ridiculous as as the affair would suggest.
Yeah, I've given thought several times to writing some kind of a math paper to see if I could, like he specifically says that, he tried to play on the biases of the, you know, the ideological biases of the people running the journals. And it seems to demonstrate to me that ideological bias has probably skewed the direction of science and the credibility and the fidelity of science far more than we think. And when I see, you know, and even like this story with Daniel Tammet, just to point this out, if I recall correctly, I looked up the researchers and they were from UCSD, you know, University of California, San Diego, and that is a premier research institution. You know, UCal, you know, universities, you know, especially within their fields, are very, very strong. And so, you know, it really disappoints me to see something like that. But I have to say, over the years, you know, I've spent a lot of time looking through university research and seeing, and because I can do so much math, so, you know, so much computation so quickly, I can look through statistics and I see stuff that looks wrong all the time. And I mean, you know, if I look at 500 research papers in a year, some of them I look at more deeply than others, but it is far more rare that I don't find what I consider major mathematical errors or, you know, leaps that don't seem justified than that I do. And
could you do a lesson on these
perhaps
statistical errors in papers?
Yeah, and for years people have asked me to do videos on stuff like this, so I'll consider that. One thing I'll say is that is a lesson in video that's probably going to take many hours to put together. Usually this Thursday, like I usually spend on average like 2 hours preparing for my Thursday night math club for adults. So, you know, with you guys, you know, so 2 weeks ago, a professor from Kentucky, who's an old friend of mine from college, showed up, and we began discussing writing a book together on how, you know, statistics are manipulated. And so it may be that along the way, like he wanted to like teach a class on it first of all, but whereas I went the professional statistician route from when we knew each other and studied together in college. He went a different route, so he's not like a statistician by nature. So, but he wanted to teach this class very badly to the undergraduate students at his university. So he and I may work together to build that class and see if we have enough material to put together some kind of a book. So maybe along the way, once we start collecting that material, I'll do something, or maybe I'll have him do the presentation. In a couple of weeks, John's gonna take over once a month for 1 week at a time, doing different topics for the math club. And maybe I'll invite Professor Lamar is his name. Maybe I'll invite Professor Lamar to give that as a presentation, or maybe I'll do one and he'll do one. There's so much material that could be covered. The different kinds of mistakes that are made, or the different kinds of ways that you can look at something and go, there's almost no way that number could have popped out naturally, and just know that somebody fiddled with a number. People don't know, what it is that mathematics can do oftentimes when they fake data. And just to give one good example, there's one that's known well in forensics, called Binford's Law. And it's something that shows up when people try to fake up numbers randomly. Like when people try to launder money, they don't understand distributions of money. If I were to pick any one of you, like say Stephen, and say, Stephen, in your primary bank account, do you know about how much money you have in your primary bank account?
Yes.
Yes. If I guessed that the leftmost digit is 1, am I right this time?
I don't know it that closely.
Okay.
I know about how much money I have in my account, but I couldn't say exactly.
Okay, and just to point out what's going on here with Binford's Law is there's a 30.1% chance that any particular bank account in the world has an amount of money with the leftmost digit 1. Leftmost digit 1. And even though there are all these possible leftmost digits, 9, we'll say 9 because we'll just skip 0 balances, but there's 9. You would think it would be like 11.1%, but why is it 30.1? And 30.1 is actually log base 10 of 2 is approximately 0.301. And basically what happens is, from the digit 1.
Your audio cut out.
Oh, did it? Oh, sorry. The log base 10 of 2 is about 0.301. And maybe I can display it like this. Powers of 2. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. I'm going to do 10 more of these.
Are you supposed to be sharing a screen?
Am I not?
I see it.
I do too.
Oh. Oh, sorry, my bad.
Okay, so this is the first 20 powers of 2. And we count up the ones that have leftmost digit 1. We get 6. 6 out of 20, which is 30% of them. And the reason, and a lot of numbers in the real world, they grow not arithmetically, like as in add 1, add 1, add 1, add 1. They grow exponentially. And money in particular grows exponentially. Populations grow exponentially. If you look at all the major cities in the world, if you said, like, what are the top 50,000 cities in population? I guarantee you that almost exactly 30.1% of them would have a population total with leftmost digit 1. Their GDPs would have leftmost digit 1 with probability 30.1%. And so when you learn about numbers that grow exponentially because of interest, or because people multiply exponentially like rabbits, when you learn what numbers are exponential and what aren't, you can make certain statements about them. This is called scale invariance. No matter how much it grows, you still have the same distribution of the numbers along the way. And so this becomes a somewhat sophisticated, it's not that, but it's cool. It's a technique for figuring out when people are faking numbers that is most useful in money laundering. And people think that they want an even distribution of digits, relatively even. And so they might launder 4,000 something dollars, and then 6,000 something dollars, and then 8,000 something, and go back to 4,000 again, and then 1,200, and then, but when in the end they only have like 8, 9, 12% numbers that have leftmost digit 1, then it looks more likely like there's laundering going on, unless there's some defined reason for those numbers to come in the way that they are. So, and in fact, I'm going to say something else, but I'll go ahead and say this. Thanks everybody for joining us for Math Club. This was I hope you guys had some fun and learned something, and maybe we'll take some of these extended topics and talk about them some more in the future.
Thank you for hosting.
I enjoyed it a lot, Matt. Thank you.
You're welcome.
Thank you.
Thank you.
Thanks for having me.
And now I'm going to go ahead and say the thing that I want to cut out of the video.
It's still recording.
I